We can repeat the calculations that we have done before to understand IP address structure. We know that 1 byte has 8 bits and a bit has the value 0 or 1. For converting the binary number to decimal number, we need to use the exponential of a 2. The exponential of a 2 says how many times to use the 2 in a multiplication. On the left side of the screen, you can see how this process is done. 2 to the power of 0 is equal to 1, 2 to the power of 1 is equal to 2, 2 to the power of 2 is equal to 4, 2 to the power of 3 is equal to 8, 2 to the power of 4 is equal to 16, 2 to the power of 5 is equal to 32, 2 to the power of 6 is equal to 64, 2 to the power of 7 is equal to 128. That we know 255 is the biggest number and 0 is the smallest number. You can calculate all the numbers from 0 to 255 by this way. Now let's start to work on the new examples. At the first example, 1 times 228 plus 1 times 64 plus 0 times 32 plus 0 times 16 plus 0 times 8 plus 0 times 4 plus 0 times 2 plus 0 times 1. The total result of this calculation is equal to 192. At the second example, 1 times 228 plus 0 times 64 plus 1 times 32 plus 0 times 16 plus 1 times 8 plus 0 times 4 plus 0 times 2 plus 0 times 1. The total result of this calculation is equal to 168. At the third example, 0 times 128 plus 0 times 64 plus 1 times 32 plus 0 times 16 plus 1 times 8 plus 0 times 4 plus 0 times 2 plus 0 times 1. The total result of this calculation is equal to 14. At the last example, 0 times 128 plus 0 times 64 plus 0 times 32 plus 1 times 16 plus 0 times 8 plus 0 times 4 plus 0 times 2 plus 0 times 1. The total result of this calculation is equal to 16. From the first example we have 192. From second example we have 168, from third example we have 40, and fourth example we have 16, which is equal to 192.168.40.16, and we have an IP address. IP addresses are identifies the connected devices, and every connected device is the member of one of the LANs. Each LAN also has a network address that identifies it. In this case, you can compare the IP address with the home address that you live and the network address with the zip code. The postman finds the neighborhood you live in according to the zip code and delivers the package to your address. Similarly, the network to which the computer is connected is found according to the network address, and the data package is delivered to the NIC card according to the IP address. To determine network addresses, the IP address and subnet must go through a mathematical process together. As a result of this process, the network address is calculated. Subnet mask is a kind of IP address that used to distinguish between a network address and a connected device address. Switch is a communication device that used to connect various devices in LAN simultaneously. Switch works on the basis of MAC addresses. Router is a communication device that used to connect various LANs in WANs simultaneously. Router works on the basis of MAC address and IP addresses and sends data package depends on the network addresses. As you know that LAN is the local area network, WAN is the wide area network, and the MAC is the media access control. Let's take a closer look at the 192.168.40.16 IP address we obtained in the previous example. As we see here, the IP address contains of 4 octets. Each octet defines 1 byte or 8 bits. The first octet of the IP address in the example is 192. The second octet is 168, the third octet is 40, and the fourth octet is 16. As we remember that each octet can take decimal numbers from 0 to 255. Let's take a closer look at the 255.255.255.0 subnet mask address. As we see on the screen, the subnet mask address consists of 4 octets like IP address. Each octet defines 1 byte or 8 bits. The first octet of the subnet mask address in the example is 255. The second octet is 255, the third octet is 255, and the fourth octet is 0. Binary number values corresponding to each decimal number value are also shown in the example. I would like to remind you again that the numerical values shown on this page are important for understanding how IP addresses and subnet mask addresses are calculated. The values corresponding to the IP address and subnet mask are placed one after the other in groups of 8 bits, which is 1 byte. Each byte is also called an octet. In this case, from the left, the first byte is called the first octet, the second byte is the second octet, the third byte is the third octet, and the fourth byte is called the fourth octet. The octets which make up the IP address and subnet mask processed with logical AND. 192 with 255, 168 with 255, 40 with 255, and 16 with 0 are processed each other with logical AND gate. These operations are done with bits and assume that 1 is true and 0 is false. Here is a truth table for the logical AND operator with 1 and 0. With this logic, if A is false, B is false, then false and false is false, which means 0 and 0 is equal to 0. If A is true, B is false, then true and false is false, which means 1 and 0 is equal to 0. If A is true, B is true, then true and true is true, which means 1 and 1 is equal to 1. When we do these operations from taking A from the IP address and B from subnet mask, we calculate the bit values that will form the network address. For calculating the first octet of network address, which is at the left side on the screen, 1 and 1 is 1, 1 and 1 is 1, 0 and 1 is 0, 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 and 0 and 1 is 0. Now we have 1, 1, 0, 0, 0, 0, 0, 0, which is the binary number of first octet of network address. To find the decimal equivalent, we need little more calculations, as you remember. 128 plus 64 plus 0 plus 0 plus 0 plus 0 plus 0 plus 0 is equal to 192. For calculating the second octet of network address, 1 and 1 is 1, 0 and 1 is 0, 1 and 1 is 1, 0 and 1 is 0, 1 and 1 is 1, 0 and 1 is 0, 0 and 1 is 0, 0 and 1 is 0. Now we have 1, 0, 1, 0, 1, 0, 0, 0. Which is the binary number of second octet of the network address. To find the decimal equivalent, 128 plus 0 plus 32 plus 0 plus 8 plus 0 plus 0 plus 0 is equal to 168. For calculating the third octet of network address, 0 and 1 is 0, 0 and 1 is 0, 1 and 1 is 1, 0 and 1 is 0, 1 and 1 is 1, 0 and 1 is 0, 0 and 1 is 0, 0 and 1 is 0. To find the decimal equivalent, 0 plus 0 plus 32 plus 0 plus 8 plus 0 plus 0 plus 0 is equal to 40. For calculating the fourth octet of network address, now we have 00000000, which is the binary number of fourth octet of network address. To find the decimal equivalent, we have 0. Now we have a network address which is 192.168.40.0. As can be seen from the examples, when the subnet mask is 255, the corresponding octet of the IP address is copied exactly. When the subnet mask is 0, the corresponding octet of the computer network address is also taken as 0.